Hey gang, integrated math superstars. I hope that you're having a great day. We're going to take a look at this module 2 practice test. I'm confident that if you look through this video, you practice these problems one more time, you understand how I correct the problems or approach the problems, or maybe go back to practice sets from module 2. I'm confident that you'll do a supreme job when it comes to the actual test. All right, sound good? So we're going to take a look here at Martin having a little bit of money in his bank account, giving 10% of his money to charity every year. That's very nice of him. So we are working with a percentage, and I think that's pretty noticeable here because 10% of the money. So I think that like as this starts off, it'll start off with 1200, but then as it goes to the next year, what's this going to have to multiply with to show how much is being retained, the amount of money in the bank? Well, we're taking 100%, but then we're deducting 10%. Remember this 10% right here. So we're really just retaining 90% of the bank account every year. So this should be multiplying by 90, or sorry, multiplying by 0.9. Well, why 0.9? Why 0.90? Why do you think 0.90 and multiplication is the way you need to do this? Well, we're taking a fraction of the amount that's left. So hopefully you're saying this is linear. If we were talking about this with an equation, we're starting at 1200 and then we keep multiplying by 0.90 t times. So this is definitely this one, 1200 times 0.90 exponent of t times. And I even give explanations here as to why those answers work. Our domain, let's think about this. Well, we don't really want to deal with negative versions of time, so that's not it. Natural numbers, recall, this starts with 1, then goes to 2, then 3, then 4, 5, and so on. Okay, so maybe it's that. If it was real numbers, this includes negative numbers, 0, and positive numbers. So I don't think real numbers is going to work here. Um, if it was positive real numbers and 0, that would include, of course, 0, but then all of the fractions in between, along with 1 and 2 and all that stuff. So I think that natural numbers is going to work the best here because we're starting with an increment of, oh, no, sorry. Well, let's think. Positive real numbers. Okay, so that would be it. Let me read through this one more time. Okay, so we have 1200 in the bank. So we're starting on day 0 with 1200, and then we keep taking fractions away. So that actually works the best because we have day 0. We could get a hold of day 1, or if we wanted half a day, we could throw in stuff like that. So positive real numbers and 0. That's what I'm saying. Let's see what else. And we can also have fractions of a year. So that's something also keep in mind. All right. Martin opens a coffee shop, gives away a free cup of coffee to 20 customers on the first day when D equals 1. I'm going to set up a little table here. So I'm going to have this as the day. I'm going to have this as coffee given out. Given out for free, but you know what I'm talking about. All right. So on day 1, 20 free cups are given out. We plan to give away 3 less free cups each day. So when we go to day 2, we're subtracting 13 here. So we're giving away 17. And this should keep going. If we keep adding 1 for the day, we subtract 3 for the coffee given out. So this is 14. Hopefully we can say that this is linear because it keeps deducting the same amount. It keeps deducting 3 every time. As far as the equation goes, do we know what day 0 is going to be? Or could we find what day 0 is going to be? We could just backtrack. Deduct 1, but now add 3 if you're going backwards. So this would be 23 is your starting term. And I'll put this in a sentence. So when I think of this now, I'm thinking starting at 23, we deduct 3 cups every day. Okay. So I think that sentence is a really big starting point because we're trying to find an equation that does just that. Starts at 23, which means that this doesn't, this doesn't, this doesn't, and this deducts 3 for every day. So this is our best option. And you have to go back to the 0 term to make that work. It's probably not negative numbers because we don't really care about the negative, like a negative day. That sounds goofy. Natural numbers may work. Real numbers, I don't know about that because we're thinking every day. Let's do this as natural numbers. And natural numbers would work because, in particular, this is starting when d equals 1. So this is beginning at 1 and then going forward. And we're not doing fractions of a day, so we just want to keep it that way. Hope that helps for those. A little bit of sorting here. We have to match up terms if they're linear, exponential, or neither. 3x plus 7 is obviously in y equals mx plus b form, so that's linear. This looks as if it's in point slope form, so let's put that in. This has x has an exponent, so I know it's exponential. This has 3x squared, so is x an exponent here? Or is x just hanging out? Hopefully you're saying that's neither. And we'll actually see terms that like x squared down the road when we graph them. This has an arch to it. Looks as if it keeps going in both directions. It has a curve. I'm going to say it's exponential. Boom. There you go. Sally's computer company is doing well. Her net income was $10,000 in her first year in business. Ooh, let me highlight some of the things here so I know what I'm reading. So we have $10,000 in her first year of business. Since then, so we see it change, the net income has been tripling every year. So first in a sentence, all right? So starting at, and it might be helpful to like legitimately copy and paste this. So starting at 10,000, how do you think this is going to be going? Are we adding something, subtracting, dividing, multiplying? Hopefully you're saying multiplying. Multiplying by how much? By 3. I'm going to say n times because starting at 10,000, that's a big deal. Okay. So let's make that equation. So starting with 10,000, I'm multiplying with 3 n times. Hopefully we can agree that this is exponential because it's multiplying over and over. Maybe I'll make a note of that right here. So this is definitely exponential because we keep multiplying by 3. And it might be helpful to also mention that this is definitely going to take on the form of a times b to the x power, which if you need to look back in your textbook, remember that a is your starting term, b is your common ratio, which in this case, 3 is our b term. And I just picked n. I could have picked x. Doesn't quite matter, I guess. Just to seal this deal, I'll say this is equal to f of n. That should help. We do the same kind of thing for 13a. Tommy is trying to work out more. Shout out to Tommy, trying to get those gains. Starts by doing 10 push-ups on the first day. He plans to add 2 additional. Oh, okay. So add 2 additional push-ups each day until he meets his goal. All right. So in this sentence, I think this one's pretty easy to put together. So starting at 10 push-ups, we add 2 push-ups. Yeah, so add by, it sounds goofy, right? Add by, but I'm just going to follow the context there. We add by 2 push-ups, but let's think about how many times this occurs, because if we made a table for this, we call this n, call this f of n, where this is the day. This is saying that on the first day, there's 10. But is this the y-intercept or something different? Hopefully you're saying that it's something different. Like, since we're 1 unit away from n, we actually want to say that this is going to be n minus 1 times. Does that make sense? Is that crazy? It should kind of make sense because this isn't our y-intercept. So we can't just say it's n times. It's 1 away. So let's say n minus 1 times. Let's piece it together. So starting at 10, we add 2, n minus 1 times. That'll be our equation. That works just fine for me. If you want to go back to slope-intercept form, by all means. But I think this is going straight to the point, getting you an equation, getting you a sentence. And I hope that makes sense how we did it. But of course, you can reach out if you're stuck. A little bit of slope, nothing we can't handle. These should look similar to the problems on the quiz for 2.5. I'm going to solve this one using the table because I got it like that. And the tables are there to help you. So jumping from 2 to 8, my x coordinates, I would be adding 6. From 5 to 7, I would be adding 2. Recall that our slope is our rise over our run, which is 2 over 6. 2 over 6, we can rewrite that because 6 is really 2 times 3. 2's can cancel. Our answer is 1/3. Boom. Let's put that on in. 1 over 3, submit it, done. For this one, I'm going to use the equation. I don't know why, just change the base. Recall it's y2 minus y1 over x2 minus x1. That's our slope. I'll call this x1, I'll call this y1, I'll call this x2, y2. Retaining the fact that they're negative terms, I'm going to use parentheses. Subtracting -3. I've got -13, deducting 5. -12 minus -3 should be addition. So think of this as -12 plus 3. So that's -9. -13 minus 5 is -18. These are both negative, so we can actually switch these to positive 9 over 18. And then simplify that to just 1/2. Does that sound good? Makes sense to me. So 1/2 is our answer here. Submit it. Done. So you have 2 ways you can do this. You can use the table, get those rates of change for x, rates of change for y, or use the slope formula. You have a few approaches for that. We're graphing a little bit for 15, y equals 1/3 x plus 2. I'm going to go pretty wild on this one. I'm going to say that this is starting at 2, we add 1/3 x times. I think this sentence is a good way to start. I could also say that my y-intercept is 2. Our rise is +1. Our run is +3. I could say a lot more about this, but that's going to be enough for this one. So let's go off of that. Y-intercepts, what 2 again? +2. Our rise is 1, so we'll go up 1. We can then run 3 units to get another point. 1, 2, 3, mark it. And we could keep this momentum going if we wanted other points. It's all good. We can keep doing this. Notice when you're really quick with it, you just see the pattern and you can just kind of map it out accordingly. I think that's a really strong way to know that you're doing this right. It's like you only have to mark out 2 points and you know they're going to be right no matter what. What's cool about this activity is that you can check your work on the next one. Notice how it maps out perfectly. So I know I'm right. A little bit of point slope form here if you need a refresher on what that looks like. I believe most of my classes are going to say that point slope looks like this: x minus x1 plus y1. But if it's written in this way, x minus x1, where your y term's on the left side, just remember that it's the opposite that you want to use, okay? So I can get a few points based off of this. I know that the opposite of positive 5 is negative 5. And again, I'm getting that from right in here. So from right here, I'm taking the opposite. I'm getting my y coordinate, which here it claimed it was negative 3, but we really want to make it positive 3. So that's 1 point. And what else can we say? We have a slope of negative 2/3. So this is something to also throw into the mix. But I'll map this point out first. So I have negative 5, 3. So over 5 up 3. Using my slope of negative 2/3, I can go down 2 because my rise, I'm going to say that my rise in this case is negative 2. And then my run is going to be 1, 2, 3. Boom. There you go. And you can keep this pattern going if you'd like. Over 3 up 2. Or in this case, over 3 down 2 if I'm moving to the right. It should be enough. Let's draw this line. Keep that pattern going. I think where I see students get tripped up here is they try to go to slope intercept form, which is okay, but you're working with fractions, and when you're running against the clock, it's easier to just say, I have this point and I have this slope, and I just want to keep that momentum going, you know? Hope that helps. What else? I know I'm right because the blue line's on there, so check me out. Point slope form, I have 2 points. I don't know my slope, so that's an issue. So I'm going to say that my slope is unknown. I'm going to use a table to get a hold of it though. So I'm going to have this as 2, 9, negative 5, 3. 9 minus 3 gets you negative 6. To go into negative 5, I would have to deduct 7. So I'm going to say that in this case, my slope, aka my rise over my run, is going to be negative 6 over negative 7, which is really 6/7. Going for point slope form, you have 2 answers you can get. You could do y equals 6/7 parentheses x minus 2 plus 9. You could have also gotten y equals 6/7 x plus 5, because remember, this is opposite here. This is negative 5, but we need opposite inside parentheses. Then after it, just plus 3. So you know what? You can actually get a few answers. This is one option. Second option, if you're so inclined, you could have also gotten y minus 9 equals 6/7 x minus 2. And what I'm really doing here is just taking the y term, putting it to the other side. Fourth option, could have gotten y minus 3 equals 6/7 x plus 5. There you go. 4 options you could have gotten. What else is going on? Slope intercept form, you're given the point 310, going through that slope of 2. I'm going to use point slope form and then convert it. So I know that in point slope form, this would be 2 parentheses x minus 3 plus 10. Distribute that. That will give you 2x minus 6 plus 10. Collectively, This is going to be 2x plus 4. There you go. That's your equation. And again, this was from we're starting in point slope right here, but then ending in slope intercept form, which is y equals mx plus b. Pushing it to the limit on this last one, I'm getting a rate of change for this table here. I know that from the year 1960 to 1980, that would be adding 20. And that's consistent with our year. For our population in the millions, 180 to 230, that's adding 50. Adding 50 again. So our slope is going to be 50 over 20, which we can simplify because they're both divisible by 10 to just 5 halves. So that's our rate of change. Getting 2 more additional points. If we add 20 to 2020, that's the year 2040 coming down the road, and also 2060. If I just keep adding 50 here, 330 plus 50 gets you 380. And then finally 430. Great time to finish the work day. Do you have any questions? Can you email me? Of course you can. You can also rewatch the video if you were stuck on something. Go back and redo problems that are similar. Let me know if I can help with anything. Thanks for watching.